Hello everyone, I'm Harshat Agarwal, part of the Technical Enablement team at OCI, and this is Virtual Cloud Network Level 200 course. Before we talk further, here is a safe harbor statement. I will give you a few seconds to read. In this session, which is part 1 of my VCN 200 level course, I'm going to talk about connecting resources available in different VCNs. So I'm going to introduce the concept of peering and will further classify peering into local peering and remote peering and see what are these. VCN peering is a process of connecting VCNs to enable private connectivity between their resources. This is like each VCN having direct or private access to the other VCN. Without peering, a given VCN would need an internet gateway and public IP addresses for the instances that need to communicate with another VCN. Since traffic between resources in peered VCNs flow over OCI Fabric, this kind of private connectivity gives you a faster and predictable bandwidth. This also gets you the flexibility to organize your resources in separate VCNs and meet requirements for things like governance and regional presence. If you really think, this also gives way to a use case where you can place your shared resources such as DNS servers, Active Directory, logging servers, such resources into a single VCN, and all other VCNs are then allowed to peer with this shared VCN and can access it privately. Doing this, customers can realize significant TCO benefits from such VCN peering solution by deploying all shared resources on a single hub VCN. We are further classifying VCN peering to be of two types: local VCN peering and remote VCN peering. Let's start our discussion by talking about local VCN peering. Local VCN peering refers to connecting two VCNs within the same region so that their resources can communicate using private IP addresses without routing the traffic external to OCI platform like over internet or on-premises network. It's important to note that these peering VCNs should not have overlapping IP addresses. Also, the peer VCNs or the VCNs which have been peered can either be in the same or in different tenancies. To set up local VCN peering, you have to create a component on each VCN side. We call it as LPG or local peering gateway. You can create up to 10 such LPGs per VCN. So here is a diagram with two VCNs, VCN1 and VCN2, and they have been peered. Traffic from an instance in VCN1, this instance in subnet A, as you can see the instance with IP address 10.0.0.15, the traffic is destined for an instance in subnet X, this instance with 192.168.0.15. The traffic from instance in subnet A is routed through LPG1 based on the rule in subnet A's route table. And from LPG1, the traffic is routed to LPG2 and then from there on to the instance in subnet X. So how we can achieve this? Let's now talk the step-by-step process of establishing local peering between two VCNs. One of the things that I mentioned in the previous slide and you have to take care is that the IP addresses in two VCNs to be peered should not be overlapping. So as a first step to establish local VCN peering between two VCNs is that the VCN administrators of these two VCNs will have to create local peering gateways on each VCN side. Next, they have to get the required IAM policies to establish the connection or peering connection. So the administrator, which is or acceptor, the administrator of the VCN, which is accepting the peering connection, has to share information such as VCN name, compartment name, and LPG name. The administrator of the VCN, which is initiating the peering connection, will share information such as name of the IAM group. Let's say if these two VCNs are in two different tenancies, then the administrator of VCN, which is accepting the peering connection, will share the tenancy OCID and also the local peering gateway's OCID, and then sets up the policy statement to accept the peering connection. Similarly, the administrator of VCN, which is initiating the peering connection in case of different tenancies, will has to get or has to share the tenancy and administrator group's OCID and then sets up the policy statement to initiate the peering connection. Once this IAM, the connection has been established, uh, once set up, administrators then establish a peering connection between the VCNs. This involves creating a peering connection between the two LPGs. The peering connection indicates that the permission to accept packets from the VCN has been granted. Administrators in respective VCNs can then update the VCN route table and also the security list and their rules to enable traffic between the peered VCNs as desired. And once that has been done, you can test the connectivity for the traffic flow. Let's talk about remote VCN peering. Remote VCN peering is the process of connecting two VCNs in different regions but under the same tenancy. And such kind of peering connection then allows the VCN resources to communicate using private IP addresses without routing the traffic over the internet. It is important to mention that the communication between the two regions does not route over the internet but over the OCI backbone network. Again, for VCNs to be peered across region, even in case of remote VCN peering, they must not have overlapping CIDRs. In order to remote peer to VCNs, we are going to use Dynamic Routing Gateway, the DRG. Just for the record, DRGs are the same type of gateways that you would use to establish connectivity between on-premises and OCI platform with the help of either IPsec VPN or through dedicated fast connect. The traffic flow is from virtual NIC of one VCN instance in one region to the local DRG and then from one DRG to its PR DRG in other region, and then from there onwards to the VCN or to the local subnet in that particular region. You might want to use this approach for high availability or disaster recovery scenarios, or simply to interconnect private workloads across multiple regions. So another important concept is the remote peering connection, or in short RPC. A remote peering connection is a component that you create on the DRG which is attached to your VCN. The job of RPC is to act as a connection point for a remotely peered VCN, and as a part of configuring the VCNs, each administrator must create an RPC for the DRG on their VCN. A given DRG will have a separate RPC for each remote peering it establishes for the VCN, and you can have maximum 10 RPCs per tenancies. So what are the typical steps to create remote VCN peering? We can start with similar environment, but this time spread across two regions where you have two different VCN environments in different regions. So you have a VCN with 10.0.0.0/16 network in region 1, and you have another VCN with a non-overlapping IP address for your VCN with 192.168.0.0/16 network. The first step is where you already have a dynamic routing gateway within each region and each DRG already attached with their respective VCN. To implement the VCN peering, you need to have IAM policies which are required for peering. Requester policy will have a resource type called remote peering from, and acceptor policy will have a resource type called remote peering to. Together, these policies will let someone in requester group establish the connection from an RPC in requester's compartment to an RPC in acceptor's compartment. Once you have the necessary required IAM policies, you can then go ahead and create the connection across two dynamic routing gateways via the remote peering connection. Once the connection is established, the next step are the same, that you have to edit the route tables and your security list in your specific virtual LAN network to forward the traffic to other VCN. Like in this example, if you have a VCN1 which is 10/16 network, within its 10/16 network there's a subnet A with 10/24 network, and it has a route table which specifically says that to get to 192.168.0.0/16 network, it needs to route the traffic to the DRG. And similarly, on the VCN2 side, there is a route table for subnet X which says that to get to the 10/16 network, it needs to go to the DRG2. So once the connection is established and the route tables and security lists are created, you can go ahead and test your connectivity. So now let's have a look at some of the important things with regards to VCN peering. From IAM policies per se, you can control who can subscribe your tenancy to another region, or who in your organization has authority to establish VCN peerings, or who can create or modify rules in route tables and security list. And once the peering connection has been established, you can also control the packet flow over the connection with route tables in your VCN. So for example, you can restrict traffic to only specific subnets in the other VCN. Also, without terminating the peering, you can stop the traffic flow to the other VCN by simply removing the route rules that direct traffic from your VCN to the other VCN. So you can effectively stop the traffic by removing any security list rules that enable the ingress or egress traffic with the other VCN. And this doesn't stop traffic flowing over the peering connection, but stops it at the VNIC level. Also, if you think that you can't necessarily control whether the other VCN is connected to the internet, and if it is, then be aware that your VCN can be exposed to malicious attacks in which a host on the internet can, or a bad actor on the internet can send traffic to your VCN but make it look like it's coming from the VCN you are paired with. So to guard against such attacks, you have to use your security list to carefully limit the inbound traffic from the other VCN to only to expected and well-defined traffic, and also implement security list rules that explicitly state the type of traffic your VCN can send to the other VCN and accept from the other VCN. And similarly, if you are concerned about high network traffic coming to your VCN, you can consider using stateless security rules in your security list. So this ends our part 1 on VCN peering. I will see you next in part 2 of the series on VCN 200 course, where we are going to talk about transit routing. Thank you.